Hi ladies and gentlemen, so today we're taking a look at theoretical and experimental and geometric probability, so this will be split up into three parts. First, let's do a little bit of review. What is the difference between permutation and combination? Well, remember, permutation is when order matters, combination, order does not matter. And how many different orders can 9 people perform a talent show? If we're strictly looking at the way we can order up a set number of items, that is a factorial, so we would take 9 factorial. And that would give us 362,880 different ways we could order 9 different people in a talent show. The student council is selecting a president, secretary, and treasurer. If there are 9 people in the council, how many ways can this be done? Well, we have 3 people that we're selecting where order matters, because becoming president or treasurer are 2 very different roles. So we're going to have 9 permutation 3. So that's 9 factorial divided by the number that we're not selecting factorial to give us 504 ways to choose those 3 people. Oops. So the first thing we're going to talk about is theoretical probability. It's all based on theory, and so nothing in this are events that have actually occurred. So examples would be flipping a coin or rolling a die. The way we find the probability of theoretical events is we use our probability notation, capital P. Inside the parentheses is whatever event it is we're calculating. We take our number of favorable outcomes divided by total number of outcomes in the sample space. So in example 1, each letter of the word probable is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a vowel? So first we need to remember what our vowels are. A, E, I, O, U. So here we have an O, we have an A, and we have an E. Those are the only vowels listed in the word probable. So using our probability notation, vowel is the event I'm looking to happen, so that's what I'm going to write inside my parentheses. Favorable outcome is 3, because there are 3 vowels in the word probable, divided by the total number of letters that are on those cards is 8. And that would give us a probability of 0.375, or 37.5% if you prefer. Example 2, taking a look at number cubes. 2 number cubes are rolled. What is the probability that the difference between the 2 cubes is 4? So we want to write out our probability statement, the probability that the difference is 4. So we're going to look at all the numbers with a difference of 4 is going to be the numerator, divided by all the ways that we could arrange these 2 number cubes. All right, the total number with a difference of 4, that would be 5 and 1, 6 and 2, this 6 and 2, and this 5 and 1. And that's it. No others have a difference of 4. So we have 4 that have a difference of 4 divided by the total number of ways we can arrange these 2 number cubes, which is 36. That reduces to 1/9. Again, you could also write this in decimal or percent form, and that would equally be correct. Example 3. So the 2 number cubes are rolled. One is red, one is blue. What is the probability that the red cubed is greater or larger? So probability that red is greater than blue. Well, we have a total of 36 different combinations of the red and blue cubed. Highlighting those where red is the bigger number. When red is 6 and the blue is 1, all the way down to when red is 2 and the blue is 1. When red is 3, all the way to 6 when blue is 2. When red is 4, all the way to 6 when blue is 3. When red is 5, all the way to 6 when blue is 4. And when red is 6 and blue is 5. That is a total of 15 out of 36, or if you reduce the fraction, that would be 5 out of 12, or again, you could write it as a decimal or a percentage and be equally correct. Now we're going to talk about the complement. Sometimes the complement will save us a little bit of time. Complement rule is when you're trying to find the probability of an event not happening, because the probability of an event happening plus the probability of it not happening together is 100%. So the complement is to do 1 minus the probability that the event does happen. Complement doesn't always save us time, but there are instances where it can. So we're going to use this problem, which is one that I know can be solved in a different way, but I want to use it as an example of the complement rule. Not that the complement rule here is necessarily the most efficient. So example 4, there are 25 students in study hall. The table shows the number of students who are studying a foreign language. What is the probability that a randomly selected student is not studying a foreign language? So the probability that they're not studying a foreign language is going to be equal to 1 minus the probability that they are studying a foreign language. Well, the total number of students is 25, we're told in the setup of the problem. The number of students that are studying a foreign language is 21. So we're going to take 1 minus 25 over 21 over 25, which will leave us with 4 over 25, or you could say 0.16. Example 5. Two integers from 1 to 10 are randomly selected. The same number may be chosen twice. What is the probability that both numbers are less than 9? So starting this one off, we're looking at, well, what is the probability that one number is less than 9? I'm sorry, what's the probability that one number is greater than or equal to 9? That would be 2 out of 10. Oops. So using the complement rule, the probability that one number is less than 9, we're going to be doing 1 minus 2 over 10, which gets us 8 over 10. Again, you could have jumped straight to the 8 over 10 answer for the probability that one number is greater than 9, but I just wanted to show you another example where the complement rule could be applied. Now, to finish this problem up, we want to know the probability that two numbers are less than 9. Well, the probability that the first number is less than 9 is 8 out of 10. The probability that the second number is less than 9 is also 8 out of 10. Multiplying those together, we get a final answer with a decimal of 0.64. Example 6. A DJ randomly selects 2 of 8 ads to play before her show. 2 of the ads are by a local retailer. What is the probability that she will play both of the retailer's ads before her show? All right, so starting this one off, we need to figure out what are all the ways that she can select these ads, 2 out of 8 ads. The order in the ads does not matter, okay, but she does need to pick 2 out of the 8 ads. So 8 combination 2, 8 factorial divided by 2 factorial times 6 factorial. And that gives us 28. So that means this DJ has 28 different ways that she can select 2 of any of the 8 ads to play at her show. Now, moving on to the probability side of this, what is the probability that this DJ selects only the local ads? Well, there are 28 ways that she can select any 2 ads, but the favorable outcome of her selecting both of the local ads, there's only one favorable outcome. She either selects them both or she doesn't. So there's only one way for this to be a favorable outcome. So 1 out of 28. All right, so that wraps up theoretical probability. The next video will cover experimental probability.